being a researcher or an experimental, researcher, you come up with all sorts of questions, whether it's your field or not. And that's been really fun to have. I wouldn't say that I'm an expert on fire testing at all, but I know my way around a fire test, and I know what a finish rating is, what it has to do with, and why it changes, and those things. And that can be important, but like also I think it's just fun to learn new things.
Welcome to the SCL podcast, filmed in the MD Acoustics anechoic chamber at their testing facility in beautiful Gilbert, Arizona. Today we welcome senior acoustician at PABCO Gypsum, Ben Shafer, where he leads sound isolation design and collaborates with acousticians, architects, and builders to develop quiet building solutions. Ben oversees product R&D, authors technical resources, and contributed to the 2025 Sound Design Guide.
So Ben, tell us about how you got into your position at PABCO.
I graduated from college and from BYU with my master's, and then I started working in building construction industry, which I didn't know anything about really. I was doing fan noise research at BYU, and so but I knew the theoretical physics foundations of structural acoustics and damping and all of that. And I just uh I just loved it. And I started working in that industry, and then took a little hiatus from the structural acoustics and vibration research I was doing to try to do consulting. Moved up here to Washington, and then the company PABCO Gypsum bought the QuietRock company that was making the damped wallboard right after I rejoined QuietRock because they wanted me back. So it was kind of all just I'm still doing basically the same thing that I was doing when I graduated from BYU, but now I'm doing it with PABCO. So
How many years ago?
that's how I ended up
How
here.
many years
That
ago?
was so. I finished my master's in October 2007. So 2007 was when late 2007 is when I started working in
18-year pro,
acoustics.
man. 18-year pro, right?
Yeah, that's right. Yeah.
So that's good. I like it. So you've been
Yeah.
That's awesome. So that's how you got into PABCO. So you literally been
Yeah.
pretty much there for 18 years. I mean, guess you bounced around, but basically the same
Yeah.
thing. And so
Yeah.
how did you decide, like, what was that transition like? Because a lot of college kids, right, they don't know, like, especially, you know, they learn their, we'll say, engineering chops, but then they get into the real world and it's totally different, right? The theoretical versus the real world. How was that transition for you?
It was really interesting going from Brigham Young University has I would say, pretty impressive acoustics research group. And at the time I was there, they had just rebuilt the anechoic chamber, and there was a lot of the state of the art equipment there, and everybody there had a really good grasp, or for the most part, had a really good grasp on theoretical foundations of physics and acoustics, and it was a really cool atmosphere. And then it's a little difficult going from that to a corporation that's trying to make money.
Yeah.
and like saying like, hey, well, can't we just use this tiny box testing apparatus and like do a bunch of tests with that, and then use those as validation for these products? And I'm like, no, because that's not how physics works. Like, if we're trying to test down to like 100 hertz, you can't use a box that's like 2 feet by 2 feet. So it was a little challenging to all of a sudden be thrust into a world that um I don't know, for lack of better wording, assumed things about acoustics that weren't actually true, and kind of trying to work with marketing and with the executive corporate employees in order to build something that's theoretically and like I would say ethically um solid. We're not saying things about your product that aren't true, like all that stuff. Working to build that was actually a real learning experience for me. Not that I have all the answers or that I'm always right about stuff, but like I knew when things were being said that were not right. So it was just really interesting to kind of like be put in that world and have to kind of assimilate to that environment and learn how to work with people in that way. So it was a really good learning experience for me, actually.
That's an interesting dynamic you're talking about, like with marketing and what can we say, what can we actually say versus what does the physics teach us or tell us is going on. Yeah, I'm glad you highlighted that. That's a real conundrum when you enter the real world and you're like, but the science is pretty straightforward on this. Like,
right. Yeah.
There's
no,
only
like
so
one example.
much we can do.
One example is they used to put on their literature, one sheet of this, damped product equals 8 sheets of, drywall. And I'm like, and I kept pushing and pushing against that. And I would be like, okay, I was like, it became like this like challenge. I challenged the CEO. I was like, okay, so here's the deal. You give me some funding, I will go to a lab and I will test those scenarios, which we haven't tested before. And if on the exact framing and assembly, if on that assembly, this product actually is equivalent to, the however many sheets of, regular drywall, then we can say that it's equivalent on that one assembly. Deal, and it wasn't. And so we took it out.
So, Ben, I do want to kind of go back even a little further than how you got your job. The thing I want to ask, and I ask this to a lot of people, is why acoustics? Like, how did you get there? Are you going to be the one kid I ever met that's like, hey, I was 13 and I knew I wanted to do acoustics?
No. That is so funny because you do those tests in high school or whatever, where they're like, you take the test and then here's the top 5 careers that you should pursue.
And you're said acoustician?
Yeah.
No. Number 1 for me was therapist or counselor.
I could see that though, Hey, you were good in college and always, you can talk and you have charisma, but you're also a good listener. Yeah. It's like,
I love people too. So it's like, it's kind of atypical for someone in my field to like really love people and love, like communicating and stuff. So, but yeah, there was that. But then my dad was a maintenance engineer and supervisor at a pulp and paper plant. And I did some internships there in the summers, and I was just like, yeah, you know what? I want to be an engineer. So that's what I went to college. Those are the classes I started out with. And I was always really good at math. Really good by meaning math made sense to me, but I always took a lot longer than everybody else. That was one thing I think was really interesting, that I think I was always very fascinated with how our physical world worked. Always. I would like look random stuff up in like encyclopedias and stuff when I was younger, because we didn't have computers. I didn't have a computer. They talked about acoustics, and I played piano and was in choirs and stuff since I was like 8 years old. And I always loved music and sound, and I actually minored in music in college and in my undergraduate degree. And so I took this physics seminar and they were talking about acoustics, and I was like, oh, wait a second. I could actually like do the math stuff and the musical type, like sound stuff. Like that sounds great. That sounds perfect. So that's how I got into acoustics.
But the music is like kind of hits everybody, right? Like you're saying, like you can do music and the science, and so I get that. That's
No, Mike, I remember you were doing stuff with like a guitar. Was it guitar?
guitar pickups and like the
guitar
whole
pickups. Yeah, I remember you were doing stuff with that at BYU.
And not to give the shout out to BYU, but guess what? It's our podcast, so we get to do that. Number one,
yeah.
We shouldn't be biased, but we're gonna be here. But number two, it's like, man, you see how much influence acoustics has had across the nation, and it's pretty amazing, like the kind of stuff you're doing, right? The research. And I want to hear a little bit more about that. Like, really, you were talking about PABCO. And like you got there and you see this stuff, you see these products. What made you sit there and say we need to do more research, or how did you come in?
Yeah.
Like, tell us your story there.
Okay, so I consider myself actually pretty lucky in that regard, because I have colleagues and associates that I've worked with or collaborated with over the years who have expressed a lot of frustration being in industry and like constantly battling to get funding for research and to have time and space to do research and kind of do what their desire and passion is in acoustics. And uh I did struggle with that a little bit at first, when I first graduated from college, but I think maybe I, maybe I just have a way with people too, where I just like kind of convinced everybody that this is what I should be doing, and then they were just like, okay.
That's awesome.
So there was a little bit of that too, but PABCO, I didn't have to do any convincing at all. When PABCO hired me in August 2013, that's when they bought QuietRock. They hired me on, and they were just kind of like I had been working with Rick Ladwig, who was at PABCO, because they sold us the gypsum panels for the QuietRock when we were making the QuietRock panels, and so I had some exposure to PABCO before, and I knew who they were. Honestly, I'm not interested in working for anyone who I don't align with ethically and research wise, and so I don't know that I wouldn't have even considered going to PABCO if I didn't already know that they were who they are. And PABCO's it's the smallest gypsum manufacturer in North America, but it's a family run company, but they're just like, I don't know, the team at PABCO. I hesitate to gush, but like I could not ask for a better like supervisor, a director of technical services team around me. Like, it's just I got really lucky. Like, and everybody's kind of on board with like, hey, here's no. It's really easy as a manufacturer or somebody who's involved in marketing a product. It's really easy, too easy, in my opinion, in our industry to kind of work the system so that you can get the highest, sound transmission loss or SDC ratings and the highest results, and then just post those. And nobody on that team is doing that. We're all like, hey, no, let's go to the lab that we know is going to give us the most statistically reproducible and reliable data that also is the most precise and accurate and in as much as we can. And sometimes that doesn't mean the lab that gives you the highest number, actually. In fact, oftentimes that's not the lab that gives you the highest number. But like I just got really lucky working at PABCO and transitioning to that company, and kind of they were just like, hey, yeah, no, like, let's do. I did within the first within the first 3 years at PABCO, I did over 1,000 tests.
Wow.
On
oh my gosh.
Steel stud framing for a research study that we were doing, that I kind of was like, hey, this is something the industry needs. Let's do it. And PABCO's like, all right. And I was just like, okay, this is great.
That's awesome. Well, I think coming from college, right? Like you're used to seeing data, and then you're like, show us the data, right? And so it sounds like you're like, we need to do this to establish baseline and have data.
Right. Yeah, exactly.
Has all that been released? Then like all that?
No, I mean, yeah, not all of it. I've done papers, and I've done we've released, I helped the marketing department come up with I'm really proud of it, a really good sound design guidebook that's really thick and getting thicker, with a bunch of assembly designs on all sorts of like steel mill thicknesses and spacings and
I use that a lot.
yeah,
You
yeah, no, it's
definitely
really,
so
no,
useful.
totally, it's really helpful, right? And it's we've tried to make it very transparent. We'll put a dinosaur next to a test that like is close to being archived, so it's old data.
There you
Like
go.
I love that kind of stuff.
Yeah.
Like just like being really transparent and trying to be really helpful to an industry that usually is used to people taking advantage of um you know uh, a system that can be taken advantage of, which we can talk about that too if you want, because I'm involved at ASTM International as well, trying to change that aspect of it too.
Tell us a little bit about that.
Yeah.
Yeah, so I mean, early on, actually, so man, it was before I got hired at PABCO. I was encouraged by Kent Gee, my uh, graduate supervisor, to join ASTM International, the American Society of Testing and Materials, um, because some of the standards in ASTM, the ASTM Committee E33 on building and environmental acoustics, there were certain standards that had to do with sound and vibration and noise, fan noise, and turbulent flow and different things like that. And so he encouraged me to join. So I joined before I even was in the workforce, which isn't usual. And then ever since then, I kind of, when I got hired with Serious Materials at the time, the QuietRock company, um, it was really advantageous to be at ASTM, to be able to be like, okay, wait a second, I'm doing these tests that are supposed to be done according to, and usually were done according to the ASTM E90 standard. I should know that standard. I should know the ins and outs of the standard and why things are tested the way they're tested, and really look at it. And the more that I did sound transmission loss testing, the more of an opinion I had about what what was a good test versus a bad test, kind of a thing. And so it was really good to be involved in that organization, and I've been involved in it since then.
How many people are on that committee? Or is it
So I don't know. There's like in the committee, so I chair a subcommittee in E33 that's on research, and there's about 160 members of my committee that
wow, that's a
That's a
lot.
ton.
but
Holy
but
cow.
only like I would say probably 50 to 70 people attend the meetings in person
Is this
every
annually
year.
or how does it? Oh, every year.
It's biannually, so, or I guess it's semi-annually. So every 6 months.
Got it.
Wow.
So is
Yeah.
this like normally would these colleagues be part of the other gypsum, manufacturers?
Oh yeah, no, okay. So actually, most of the which actually it's very impressive to me. Most of the members of ASTM in the committee in ASTM that I'm a part of, most of the members actually are, or majority of the members are actually acoustical consultants and engineers. They're not in manufacturing, which I think is good. It's good to have a balance with, if it were only manufacturing people, and in fact, you have to maintain balance in those E33 committees. You can't have too many producers or manufacturers. Which I think is a good thing. You need it's good to have like a broad array of humans who have different interests involved in that organization, I think.
Do you ever get into like fire testing and fire rating, and like, are you an expert at that, or do you just stay in your lane?
No, actually, so okay, that's a good question. That's another thing I love about PABCO, is that there's a lot of opportunity and a lot of people open. Like I've been open to, I've gone with all of our tech services people at different times, and I've taken them to an acoustic test series, and I'll answer questions, and they'll, we'll do this like kind of cross pollinating, education stuff, and then I attend fire tests as well. And I have all sorts of questions about like, well, why are they putting the
Thermocouple.
the thermocouples? Why are they putting the
Gotcha.
thermocouples here? Why do they, you know, how far apart do the thermocouples have to be in order to, like, you know, there's all these questions. And being a researcher or an experimental, you know, researcher, you come up with all sorts of questions, whether it's your field or not. And that's been really fun to have. I wouldn't say that I'm an expert on fire testing at all, but I know my way around a fire test, and I know what a finish rating is, and what you know, and what it has to do with, and why it changes, and those things. And that can be important, but like also I think it's just fun to learn new things.
Yeah, no, that makes sense. That's awesome.
Yeah, speaking of learning new things, there's going to be a lot of people here who are going to watch this or listen to this who don't know what a QuietRock is.
Oh yeah,
and what does what makes QuietRock so much different than, say, you know, 5/8 inch Gyp Type X? Like they hear these terms, but a lot of them are like, I go to the Home Depot, I buy drywall. I don't know what you're talking about.
No, that's great. Oh no, thank you so much for bringing. It's so funny. I'm such a I'm not in sales, so I'm like, I don't even like, I should be talking about that. That's funny. No, but thank you for bringing that up.
That's why we have Robert here. That's why we have Robert here, right? Like, he brings us back down to earth again.
Yeah, totally. That's great. Thank you. I'll try and be quick about this, the intro kind of fundamentals, but like, what a sound wave is, a pressure wave. I talk and the sound wave radiates from my mouth, and eventually it's going to hit a surface. And when the sound wave hits the wall vibrates, even if I don't see it. You know, the wall in front of me is vibrating, and I'm not seeing it, but it is, and it's going to radiate the sound back into the cavity that's behind it, and then re-radiate it through the wall, and vice versa. So when any sound wave comes in contact with a surface, that surface reacts, you know. And a gypsum panel is composed of rock. You know, it's mostly calcium silicate dihydrate. So I've gotten a little bit into chemistry as well, but I'm not a chemist either. I'm not a chemical engineer, but according to the ASTM standard specification for gypsum panels, it has to be at least a certain percentage. I forget what it is, but 90-something% this specific mineral, right? So it's basically rock, and it's reformed into a panel, a monolithic panel. And when a sound wave hits a sheet of steel or a monolithic panel, or any kind of panel or system that's pinned to a frame, it'll vibrate. And what QuietRock does is it basically just reduces that vibration. So there are a lot of ways to isolate sound through partitions. You can use double studs so that, you know, one frame is vibrating independently of the other frame. That's decoupling. Or resilient channels or isolation clips or whatever. That's decoupling. That's a totally different mechanism. Or you could just add mass. You just add layers and layers and layers, or have a concrete or something, and you're adding mass, adding enough mass that will also reduce your sound transmission through the wall, increase the sound isolation. Or you could mess with your air cavity, which I've found doesn't make huge differences, but can make a difference. There's a difference between not having any insulation in a cavity and having some insulation in the cavity. But then something that hadn't been applied, what's interesting is that, like, in the 1930s and 40s, constrained layer damping or damping technology was used. It started to get used like wildfire in that's funny. Anyway, it started to get used a lot in naval in the Navy, right? So so submarine fuselages, and they started to use it. Mike, you know, they started using planes. As like damping tape, or they would put like a damping tape in between two sheets of steel or iron or whatever, and create these damped beams or panels. And basically what it does is that you've got this like shearing motion when you have two rigid materials that are only connected with a rubbery viscoelastic polymer. They shear, and then a lot of that energy is used. A lot of the vibrational energy is used in that shearing instead of being re-radiated into the cavity.
I'm picturing a peanut butter jelly sandwich, you know.
Yes.
I am a little hungry.
Yeah.
You hit that top layer of bread, and the peanut butter and the jam kind of eats up the energy.
Right, except the bread in this case would be incredibly stale, and that would be great. Yeah, you want
toast.
You want your constraining toast. You want your constraining layers. It's actually more optimal for your constraining layers to be more stiff. In a damped system, a constrained layer damped system. So anyway, that technology existed since the 1930s, 40s, 50s. And was used widely in the military, and then in the early 2000s, a really smart CEO and investor was like, "Hey, wait a second, what if we use this in buildings? You know, that way you could reduce the sound through a building partition, but not have to increase the thickness of the partition much, or add all these really complex." Springs or things that add a bunch of labor to the wall. You just put on this. You replace your regular dry gypsum wallboard with like this damped gypsum wallboard that just doesn't allow it to vibrate. And so that was pretty smart. And that I think the group of people who did that didn't even have a background in acoustics, which is, I think that's awesome. Like,
yeah,
they were just like, hey, this is the thing let's do this, I think that's great.
Just a big gap of like 50 years. Like, why did it take them 50 years to figure that out?
I don't know. I don't know. I honestly, I
that's
guess
amazing.
Yeah, I mean, and it is engineering wise and manufacturing wise, it's tricky to do. To make those panels, so maybe that's why. I mean, just the manufacturing side of it's a little tricky to do that. But yeah, definitely. Sometimes I would ask too, like, well, that seems like a slam dunk, but especially as like population increases or people move to urban areas where there's less room, or you're building a hospital and you want to be able to squeeze in one more unit at the end of the corridor. And if you save an inch per unit along the corridor, you could build a whole nother unit,
Frees up a lot of space when you're not using 8 panels.
Yeah, no, that's right. Well, I rule of thumb, nice. Like how many panels is a layer of QuietRock compared to regular? Apparently it's not 8.
No, see, that's a good question. And I would say it varies widely. Like if you were to make a really well decoupled double stud partition with like, some kind of gasketing or springs where the studs are really decoupled, your damped panel is not going to drastically improve the sound transmission loss performance of your partition over a same weight, gypsum panel. It'll just perform better at just maybe like 2 third octave bands, 2 frequencies.
Gotcha.
But if you're on a single stud wall partition,
with a resilient channel, maybe a 2x6 wood stud wall.
or even something like that. Even resilient channels, you get a bit more bang for your buck with the damped panel for sure in terms of performance. So yeah, like the less decoupled your partition is, the more of a difference you're going to see between a damped panel and an undamped panel.
Gotcha.
Yeah.
It just all depends on what you're using it for, right?
That's right. That's right. So I don't even know. I didn't even answer your question because
I know.
I don't think there is. It's like just depends on.
There's so many variables that go into it, right? On like how this is going to work. As opposed to saying, yep, we do it this way and then throw that up, it's going to work the same way. It's just like saying, hey, throw 8 layers up when really 4 layers does the same thing.
Right. Yeah, totally.
No, and I also love that you bring that up. So many times in the architectural acoustics world, people want to know, well, what's the improvement for this one product versus an XYZ substitute? And it's like, well, it depends on the assembly. It's the whole assembly and how it's constructed and constrained that allows the sound to transfer, as opposed to just this product versus that product.
The question I love the most is when they're like, what percentage more?
Yes, percent.
Yeah, percent. Everybody wants to be percent.
Oh man, what does that even mean? Like in terms of, do you want a logarithmic percent? Like in terms of dB?
I know. I'm like decibel. Well, I always am like, well, the decibel is a ratio. So I mean, you're kind of already getting a percent unit. You know, like But it's really complicated. It's not linear. And then people are like, what do you mean not linear? And I'm like, well, your ear doesn't hear noise linearly. Like, you know, like, So it opens up the whole. I try not to bring it up like that, but like we do. Oh, in our sound design guide, I worked with our marketing people who don't know anything about sound. And we kept going. We went back and forth for months. And I sent them like, here's dB, how you can explain how decibels are nonlinear or whatever. And we went back and forth for months, and we came up with a really cool kind of side article. It's like a page or so in the sound design guide that talks about that I thought was like, it ended up being a really cool article, I thought, because it makes it simple and palatable, but still really technically accurate. And
we're gonna show that up. We're gonna show that up in the video. So we'll see.
Yeah.
What you've got all this experience, right? All this time in your career. Let's say we're mid-career, right? And so my question to you is like, what to date has been the most exciting for you? What's the or exciting or most, something that you've worked on that you're really proud of?
I would say Well, first of all, I always, it's funny because I get asked that question. I've done the BYU Acoustics Research Group meetings, and I've done other invited, talks or whatever, for industries and stuff like that, to be like, oh, how do you, what do you? And I gotta say first that I just me haven't done anything in this industry alone ever. Like, there's always a team of really awesome humans like we're collaborating with and working with that I actually don't really feel a lot of like individual like pride and like stuff that I've done. I feel a lot of like gratitude about like I haven't done anything that's been just me. So I'll say that first, but then I think something that we've done that I think I'm really proud of and that's why maybe I mentioned it, is the test series that multiple test series. Now we're coming up on almost 2,000 tests.
Wow.
of characterizing steel framed sound transmission loss, measuring things I never even thought of. We were measuring at first just mill thickness, and then steel stud width, and then steel how many knockouts are in the steel stud and at what frequency, with the knockouts. Does that make a difference? What about yield strength of steel? Does the yield strength of steel make a difference for the same mill thickness of steel? Like, this is the stuff that really excites me. Like, I love asking questions that no one has an answer to, and then being allowed to go to a lab and be like, let's figure it out, or figure out, if we're not able to figure out, why aren't we able to figure it out? And that's why I've done all this research on uncertainty in sound transmission loss testing, because I would go to labs and I'd be like, wait a second, how am I going to this lab and getting this result and then sending the same exact materials to this lab, having to build the same thing and get something way different, so those are the kinds of discoveries, I guess, that I live for. I love that stuff. Like, a lot of people, it's so funny because I'll go to lab. A lot of lab directors will be like, you're weird. Like, I'll go to labs and like something will happen that's totally unexpected, or like, and it's usually a result that's way lower than we thought. And I'm like, what? No way. Like, can we test it again this way? And let's see what, and they're like, usually people are like, hey, give me the number I want, and I'm like, I don't care what number we got. I just want to know what's going on. So I think I just get really excited about that kind of stuff.
That's awesome.
Yeah, it's so helpful in our industry to have people that are out there just trying to find out what are the actual facts and how does everything work. So thank you for bringing that to our industry. It lifts all the boats.
And seeing that need, you know what I mean? Like that, like you're saying, like you know, as a young person, as a young acoustician, you get some internship, but then as you go up, you're always looking for data. So that's awesome.
Right. No, I can't imagine. See, I always empathize with consultants because I'm like, I try to empathize. I can't sympathize. I was a consultant for a year and that didn't work out for me. But like, I always try to sympathize because I'm like, man, or empathize, I guess, because I feel like if I were a consultant in this industry, I would be constantly frustrated at like, wait a second. Like I did this like test. I saw a test of that exact same thing from this manufacturer, and it's like totally different than this one. That's pretty much the exact same thing too. Like, why? That shouldn't be a thing, Like, and so I don't blame anybody for that. And so I try to. That's part of what motivates me to be like, okay, let's figure this out and fix it.
I've got another question for you before we wrap up. If you go back like 20 years ago to sophomore, freshman that's undeclared major, has some math skills, some science skills, and inclination, what would your advice be for them to help them pick a major?
Without any question, I would say figure out what excites you and what you want truly. Like, do the internal self work to really ground yourself in what actually excites you, and it will change over time, and how it and I still get excited about acoustics, but I think that's the number one. I'm not one of those people that says that if you love what you do, you'll never do work or whatever. It is work. It's always work, like there's work in everything we do. Like, and it's not always, even with what I enjoy, it's not always, it's sometimes tedious and it's not always the best, but I do still get excited about acoustics. And I would say, just find something that you're excited about. What excites you? What really excites you? And do that.
Well, Ben, thanks for joining us today. We really appreciate your message. Appreciate all the words of wisdom. Those are great carrots.
Yeah, of course.
For us, and we're grateful for your time. Thanks.
I thank you so much for inviting me. I really appreciate the invite and the openness and the questions. You guys were great.